Okay, hello everyone. Thanks for joining our webinar today. If you have any questions during the session, please submit them by the Q&A button at the top of the interface. Those questions will be answered at the end. The webinar will also be recorded and you will receive a copy of it delivered to your email account after the webinar. Now, I hope you enjoy, and I'll now hand you over to our expert, Rainer Keller, who's the Senior Software Engineer at the Qt company. Over to you, Rainer.
Yeah, hello everyone. I'm working on the Qt OPC UA module. And in this webinar, I'll show you how to use the Qt C++ API to establish a secured connection to an OPC UA server. This webinar is not a general introduction into Qt OPC UA or Qt OPC UA module, but it will just cover the topic of secure connections. And Qt OPC UA is part of the Qt automation package, which you can get from the Qt company. And we have added a C++ API for the secure transport. It's new in the 5.13 release, which will be available end of May, hopefully. But you can already get the source code through the code repositories if you want to have an early look. And the whole security extensions are in technology preview state. This means it's not fully ready, but you can already look at it, give feedback, and if you want to use it, the API may still change during this phase. And at the moment, we have two backends, the Open 62541 backend and the UA CPP backend. And the current support is only by the UA CPP backend, because for the Open 62541, we have to wait for the 0.4 release to support it. On Gerrit, there are already changes which you can apply manually to make it supported by the master branch, but it's not officially supported in the 5.13 release. Now, short introduction how the connection setup works. The first step is to instantiate the client backend. This is the same also in 5.12. Then you have to perform a server and endpoint discovery. This is a second and third step. This was optional in 5.12 and is now mandatory with 5.13. The new security steps are also mandatory if you want to use security. And they are new in 5.13. This is to select the secure transport and to set up the security parameters, of course. And the last step is the same as before, then you connect to the server. So how does this work? You first have to instantiate the client. For that, you ask the OPC UA provider for the available backends. At the moment, these are UA CPP and Open 62541. Because as I told you, the security features are all only available with UA CPP, so you have to instantiate this backend. And then you create a client for it, which we then use for all the other steps we now will do. In the client, you have then to perform the server discovery, and the client has functions for that, namely find servers, which you pass the discovery URL, and when the discovery is done, you will get a signal find servers finished and will be supplied with a vector of all the found application descriptions, namely the servers, which are registered with the server. Application description you will get contains some information about the server which was found. It has, for example, a name, an application type, resource identifiers, and the discovery URLs, which we then use for the endpoint discovery. An example code may look like this. So you connect the signal to your own slot, which is a lambda in this case. And the lambda takes a vector of the found servers, a status code, and it also gets the original URL you requested. Then you have to check if the status code is a success status, that the actual query was successful. And if it was, then from the vector of servers, you have to choose one you want to use. This is up to you. So depending on the type of service you want to talk to or whatever, you have to choose one. And of that, you choose also one of the discovery URLs of that chosen server, and then start an endpoint request. But to trigger this first step, you have then to call the find servers method with the discovery URL of your discovery server. Okay, next slide. With the endpoint you have chosen in the code before, you have to do the endpoint discovery. There's also, again, in the client method that allows you to request the endpoints of that specific server. And you again have a signal when the request is finished. And in this signal, you get a vector of the endpoint descriptions which the server supports, and the status code again. Endpoint description has the URL and the server description again. But yet now most important is for security is the security mode and the security policy and the supported user tokens, which we then use to specify the security mode we want to talk to the server. And again, this looks like this. So the finished signal, you connect in this time again to a lambda, and it will receive a vector of the endpoint descriptions. You have to check if the status is a OK status or if it failed. And if it's OK, then you can choose one of the endpoints. This is mostly depending on which type of encryption you want or how secure the connection should be. If you have chosen one, you store it in your endpoint description. And then you have to set up the security before connecting. I will cover this in a later slide. And after that, you connect to the endpoint you have chosen. And to start this whole lambda, you then start an endpoint request to the server URL you have chosen during the server discovery. Before you can set up the security, you have to ask the backend you have instantiated which security policies are supported. And for example, not all backends may support all security policies or all authentication mechanisms. You can query the instantiated client for a list of security policies and supported user token types. So you should make sure that your backend is actually supporting it. For the UACPP backend, for example, the supported security policies are the ones listed here. So we have actually 5, and the none policy, which means it's not encrypted nor signed. And when you get the endpoint description, you should check, and you choose one of the endpoints, you should check if the endpoint security policy is actually included in the supported security policies to make sure you are able to connect to this server via that policy. And additionally, here in this code, I also excluded the none policy specifically because if a server does not support any, or if the supported securities policies have only the none policy, that we refrain from connecting unsecured to a server. The next step is to set the authentication information. This is needed to choose whether you want to connect via username and password, or if you got a certificate to connect to the server. Actually, we are supporting 3 different authentication mechanisms. So the anonymous one, the username and password authentication, the username and password, and the certificate authentication. And you just instantiate this authentication information class, and then call set certificate authentication if you want to use certificates. And then you tell the client via set authentication information, you can pass over that to the client that it will actually be used. In this example, I show how to use certificate. And in order to use certificates, you also have to set up a public key infrastructure configuration. This is used to tell the backend where your certificate is, where your certificate revocation list is, and all this kind of configurations. And for that, the public key infrastructure configuration has to be set with some parameters. First of all, of course, the client certificate, which we'll use to actually authenticate your client against the server. Then the private key file to make the client able to sign requests from the server. Then you have to set up the trust list directory. So which server certificates you trust, for example, it's the directory, the revocation list directory, the issuer list directory, and the revocation list directory. And you can get an application identity from that. I will talk about that later. So this application identity you can get from this configuration is based on the client certificate file, which you set in the first function here. Typical setup looks like this. I created a directory next to my application. The application path can be retrieved by the application dir path. And I just named the directory PKI, and which is directly next to the application binary. And relative to that directory, I have the certificate file, the private key file, and then directories for the trusted certificates and so on. And this code is actually taken from our OPC viewer example, which is included in the source code. When I've set this, all the parameters up, I can transfer the PKI config to the client to use it. And the next step is then to set the application identity. This is used to identify your client to the server. And it also has some properties which you can set. Its application URI, its name, the product URI, and its application type. And to set it up, there's a convenience function, because all these values, let me go back, all these values have to match exactly the certificate you are using in the PKI configuration. And because to avoid typos or any else other errors, there's a convenience function in the PKI configuration that retrieves the application identity for you from the certificate. So you don't have to set the parameters up yourself. They are just extracted from the certificate. And you can also set this identity directly to the client. The alternative setup is when you want to do it yourself. With some examples here. So I just took some dummy values for product URI, application URI, name and type. And then you can have to also set it to the client. So the next step then, now we have all connection specific things set up, and we can then connect to the endpoint. And in case of connection errors, the signal here will be raised with some kind of error state. And I actually noticed that here's an error. This is not a URL, it's an endpoint description. It's wrong in this slide. And the callback for the errors is when a secure connection is established. This will be called with an error state. And this allows you to determine what actually went wrong during the connection state. So if there's some certificate error, or if the certificate is not trusted, and it has a function that you can determine if it's a client-side error. So for example, if you connect to a server which certificate is not trusted on the client side, then you can check if the error is on the client side, and if the connection step is a certificate validation, then you can set the error state to set ignore error to true. Because the error state you get is a pointer, and you can modify the object over there. So if you set the ignore error state to true, you can ignore client-side errors. If it's a server-side error, so for example, if your certificate is not trusted in the server, you can of course set the flag, but it will not help you because the server will ignore the connection then. Yeah, and finally, to connect to the endpoint, you have to call the function with the actual endpoint description you have chosen and set up. To recap, these are the 7 steps you need to take for the secure connection. So first is to instantiate a client within, for example, a UACPP backend. You have to do the server discovery. With find servers, you have to do an endpoint discovery with the chosen server. Then you have to set the authentication information, the PKI configuration, the application identity, and then you finally can connect to the endpoint with the connection which was set up. So again, to sum this up, it will be available with the Qt 5.13 release as technology preview. So you can still, if you have feedback or other comments about this, you can contact us. So we can still take your suggestions in consideration until we put this in final state. So yeah, and if you want to have a look right now before 5.13 is out, you can also have a look at the source code in Garrett. But otherwise, you have to wait until the 5.13 release, which will be hopefully end of May. And yes, that was the stuff from the presentation I have. Then let's check the questions.
Great, thank you, Rainer. So yeah, for everyone who has joined, please submit your questions through the Q&A button at the top of the interface. There's no questions at the moment, but I think there might be a few kind of frequently asked things or kind of interesting things that maybe, Rainer, you can share while we wait.
Yes. So we're using, in this example during the presentation, we used certificates for connecting. And currently you have to get the certificate beforehand and install it on the system. And maybe some will ask if there's some kind of automated way to retrieve those certificates from the server. And actually I'm working on this. So soon, soon there will be an API to actually create and retrieve certificates from the server using using the GDS API. And some other thing I could mention is that all the discovery steps usually take a bit of time to perform. And if you want to connect to the very same endpoint every time, because you have a fixed setup, you don't need to do the server and endpoint discovery every time. You can still just save the endpoint data in your application and then load them again and then set up the endpoint description directly and use it during the connection phase. So you don't need to redo the discovery parts every time. So there's a question. What is the typical time length of a certificate? You mean the validation date, probably. This depends on the server. So what clients usually do, they create a key, a private key, and with that they create a certificate signing request, send this to the server, and then the server will sign this request, and then the server will sign this with a validation period. And it's depending on the server configuration how long the certificate is valid. So you cannot choose that from the client side because the server decides that. So the whole thing of this API is only the client side. So we are at the moment not providing an OPC UA server within Qt. But if you have comments about what or if a server would be useful for your company, then you could contact the product manager, Michele Rossi. He's currently collecting feedback from our customers on the server side topic, if that's actually requested or not.
Right, I think that is the only question we have. I'm just going to quickly type in Michele's email here, but it will also be in the follow-up email. But if that's all the questions we have, I'd like to thank everyone for joining, and thank you, Rainer Keller, for your informative presentation. If you do have any more questions that come to mind that we didn't go through, please send us an email at either info@qt.io, or you can get in contact with Michele or Rainer. Those emails will be provided in the follow-up email. But until then, thank you so much for joining, and I wish you a great day. Goodbye.
Bye.